Welcome, computer scientists, to CSC 222 Software Engineering. I'm Professor Gary Locklear, and I'm glad you're here. I'm going to switch over here to my PowerPoint. I will have some things to share with you on most days. In just a little bit, we're going to jump into Blackboard, and I'm going to show you that everything you need for this class is going to be online at Blackboard. Sometimes people ask me, well, how is the class? Well, what would you expect the instructor to say? This is one fun class. And to prove it, look, here's a Dilbert comic. I'll read it and then I'll explain Dilbert. First panel, that's the boss. From now on, this is going to be a fun organization. Wally asks, when are you leaving? I had no idea that a rubber chicken could hurt so much. Thank you. Dilbert, if you're not familiar with the Dilbert comic strip by Scott Adams, it's kind of a favorite of computer science and information technology people. Scott Adams worked in the industry. Dilbert is an engineer, and they deal with all kinds of tech issues. And the scary thing is, it may seem like the boss and the organization is like totally bizarre, but unfortunately, it's like that sometimes out there in the production world. But don't forget, this will be one fun class. I need to give two shout outs. First of all, to Professor Josh Tallman for allowing me to teach this class. If you don't know, I'm not on the full-time faculty of Concordia University, Irvine. I'm an adjunct professor. I am, however, a full-time faculty member at Concordia University, Wisconsin. So I do teach computer science, and I do teach this course, software engineering, at your sister school in Mequon, Wisconsin. And also shout out to Dr. Thomas and the other administrators who, I like Irvine. I like Mequon. I like my Concordia University. And I also like the things that are going on there at Concordia University, Irvine. So if you're part of that, good. And hopefully I can carry the banner forth and not make too many mistakes. You are computer scientists. You are taking a class called software engineering. Many of you may want to be a software developer in the future. So question, what is a software developer? We're going to be talking about that. I just like to begin throwing out some news articles, and you can do the searches as well as I can. This is from US News and World Report /Money, where they always list their top jobs. 2 years ago, I think this is from 2020, 2 years ago, their number one job was software developer. I'll show you the 2022, that's dropped to fifth or something, but that's all fake. This is the best job there is. Software developers invent the technologies we sometimes take for granted. Okay, I think we know about that. Now, warning, when you take a look at the median salary, notice that is the median salary. You probably won't be starting at that. I caution my students in Wisconsin, because we're part of the Midwest, that salaries are not going to be as high as you see like on the West Coast. I oftentimes get students who get a job offer from Google or Apple or somewhere in Silicon Valley or Southern California. They say, oh, look at this. I say, yeah, that's great. Now I want you to look up how much housing is. Okay, enough said. This is from Glassdoor. Every year, Glassdoor ranks their best jobs. And in 2022, you'll notice that they're top of their list here. These are all technology jobs. I mean, there's one, number 8, that specifically says software engineer, but many of these other, DevOps is just a part of software engineering, full stack, same thing, an architect. Many of these are really part of software engineering. So, do you want to be a software engineer? The prospects are great. 2022 version of US News and World Report /Money magazine, they rank software developers number 5 in the 100 best jobs. Over the next years, and I forget if this is a 10-year or 5-year, 400,000 openings. Can you get a job? Can you get a good paying job? The answer is yes, absolutely. But you knew that already. I'm pointing this out because software engineering, this class, is going to be a little different than some of the other classes that you've had so far at Concordia University, Irvine. All right, Dilbert, sorry, I got to have some Dilbert ones. It's okay to laugh too. You don't have to unmute, you can just laugh. I heard you had 3 full-time jobs during the pandemic. How did you get it all done? I worked from home and told all 3 employers I couldn't complete my projects because of supply chain issues. So you're a liar? I prefer opportunist. See, I mean, this is it exactly, right? I can't get things because, oh no, supply chain. Ah. All right, onward. There is a textbook for this class, but you don't have to pay for it. It wouldn't be fair because I wrote it. And that seems a little disingenuous to make students buy the professor's textbook. It's not the full-blown thing. There's an actual EPUB that you would have to buy, but I own it. So I pulled a lot out, including some pictures. And you're going to find this serialized every week online at Blackboard. I do want you to read it. It's important. I'm not going to read the text to you. We're going to talk about some other things. We're going to do software engineering a lot, but this is some good background information. Software engineering, the idea, implementation, and interaction of professional software creation. And look, there's a car. Automobiles are one of my hobbies. Why should you read the text? Well, because there may be quizzes. Just strike out that word may. There will be quizzes. Each Monday, I'm going to give you a little quiz. It'll be on Blackboard. Give you a little quiz over the previous week's reading. Nothing painful. Be very obvious. And it is open book, but it's timed. So you'd sort of have to know the general ideas and don't sweat it. You'll be okay if you actually read the text and pay attention in class. If you have any questions as we go through class, feel free to let me know. You can post it in chat. I'm not always paying attention to that little bit of my real estate there. So if you post something I don't answer, feel free. If you want to unmute and just say the word question, that will alert me and I'll stop and feel free. I know it's a little weird here. And the hard thing is it's hard for me to read faces because I can't see you all at once like I can in campus. And some of you can't see it all. All right, good. Let's jump into Blackboard. You at Irvine are changing your LMS. You know what an LMS is? Computer scientists, you know everything is a TLA. TLA, 3-letter acronym. LMS is a learning management system, and Blackboard is an example of that. So let's jump into Blackboard. Hopefully on my screen, you can see I've just jumped into Blackboard. Now, if you go to Blackboard and see a class that says CSC 222, but get in it, there's nothing there, you can't see it, let me know. Because when I went to set up the class, there were 3 courses that said CSC 222. This is the one I chose. All right. I think most people are in it. There's like 35 people listed on there. So if you can see more than one, find the one with CRN 20202, or it says OL1. All right, OL for online, and we are doing this thing via Zoom online. For me, and I know everybody sets up Blackboard differently, but for me, well, homepage, okay, fine. If you want the course syllabus, if you want the course syllabus, Mm-hmm. All right, let's try this again. This is the beauty. You know what it did. It just timed out, right? I think that's what it did. Who knows what it did? From this website, my password is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not. Okay. How you doing out there? Good. All right, I think I got it back. If you're looking for the student syllabus, you'll find, I'm afraid to jump into this, what's it going to do next, but here's the student syllabus. The thing that will interest you most of all, by the way, I'm trying to get in the habit of checking my CUI email. So Gary.Locklear@CUI. If for some reason you need to get a hold of me quicker, email me at CUW. That one is pinging me all the time. It looks like a number of folks were able to join Zoom okay. So there's the link for it, but you knew that already from an email message. Lots of really important information. I encourage you to memorize all of that. Probably most important to you is the very tentative schedule. Only very tentative because, well, sometimes things happen. But what I want to do is stick to when the end of the unit is, September 26th for our first exam. We may talk about that. Well, we'll count on these end dates. If I can't get to all this stuff in the middle, that's okay. And by the way, if we have exams, our third exam would be during the final exam period. If we have exams, the third exam will not be a comprehensive final. We're doing 2 comprehensive projects. So it's just a unit exam, but we do it during the scheduled final exam period for this class. I don't know if that's the 12th, that's the Monday of finals week. I'd have to look that up. Now, for you, come on. I've got too much stuff here. Too much real estate going on. Come on. There you go. Most of what you'll be interested in for this course is found under the content link on Blackboard. This is the link again. After a while, now you can see a bunch of other stuff because I'm no longer in student preview mode. But the only thing that is open to you right now is Unit 1. You're going to first, from now until September 26th, you'll find everything you need for this class in Unit 1. And they'll be arranged sequentially. So here's the reading. This is the text again. So here is week 1 of the text, yada, yada, yada. Okay. In addition to the text, most days I will have an outline. This outline is sort of a listing of the important things out of the text and the things I would love to talk about if I had enough time. And today, wouldn't it be great if we just said, hi, how are you logistically, and then check out? We can't do that today. I'm sorry. I'm going to explain that in a little bit. So the outline is sort of a condensed version of what I think might be interesting that day. Some other handouts on things. And yeah, there's actually an assignment today. Don't panic. We'll talk about it later. Today is day 1. Wednesday is day 2. We meet Monday, Wednesday, 4:10, 5:25 Pacific Daylight Time. Are there any questions about Blackboard? The other thing I'll mention is we will submit assignments online at Blackboard. I'm going to talk about this first one and how to do that, but I think you're probably all adept at Blackboard. If this happens to be your very first semester here at Irvine, then hook up with somebody else who's used Blackboard before, or I know you have lots of support people there too that can help you with that. Any general questions right now about Blackboard, perhaps?
Excuse me. I couldn't help but notice some of the dates were old. Are those going to get updated, or are we just going to have to track the syllabus?
Oh, really? Are they up? Are they on Blackboard? Are the dates old, or on the syllabus are the dates old?
The Blackboard. I
Okay.
just it said September 2020, and it was September 7th, whatever, something like that. I just didn't know.
Okay. All right. Yeah. Yes, my fault. I ran date management and it didn't do what I thought, and I did. Okay, my fault. Yes, those will be updated. Good point. You need to know when things are due for sure. So not only will I say, but Blackboard will be updated. Great question, and thanks for verifying that for me. Anything else about Blackboard, perhaps? All righty. I want to play a game with you called What's the Difference? When you read the text, you'll find out that I'm a wannabe race car driver. I'm in no way a race car driver. When I was getting my SCCA competition license, the instructor said, "You do have a day job, right?" Anyway, I fancy myself a car person and part-time race car driver, very part-time. So I want you to think about this for a minute. As a matter of fact, I'm going to ask you to post something in chat in just a minute. All right. So first of all, what's the difference between me? I'm a rank amateur. I'm not a professional race car driver. I've had a number of my cars on the track, both drag strip and road course and other kinds of things. But I am in no way either a good or I'm a rank amateur competition driver. So what's the difference between me, race car driver, and that person who you do not know? That person is Oliver Gavin. Oliver Gavin drives for Team Corvette. Chevrolet sponsors Corvette in I'm trying to remember what class they are in. They moved to a new class this year. Anyway, Oliver Gavin is a professional race car driver. This is the C8. Corvette people talk about generations, C for Corvette, and followed by a number. This is the 8th generation, the mid-engine Corvette, and this is the race car version of it. They field 2 teams, used to be the 3 and 4, and now it's the 73 and 74, whatever they are there. What's the difference between me, wannabe race car driver, and a real professional race car driver like Oliver Gavin? Would you think about that for just a few minutes, and then would you do me a favor? Would you find the chat button in Zoom and just tell me a thing or two? What's different between me, amateur? Yeah, these are all good. Give me something. What's the difference? Keep going. If you didn't have a chance, go. As you're reading other people's, don't worry what they said. I'm just interested in what everybody would have to say. So, yeah. These are good. Professional racer has a lot of experience and training in different driving conditions and car setups, able to perform quick thinking under pressure, correct mistakes, perform effective overtakes, manage tires and car conditions throughout the race. Wow, Tim, that's pretty good. Ryan, Oliver Gavin gets paid to race. You bet he does. Experience and skills. Skill, car, resources. Experience, training and expertise. Experience and money. He's one of the best at what he does. Built different. I don't know if that means me or the car. Both, actually. Oliver has training. They have experience, sponsorships. Good one. Time and dedication. Practice and time perfecting skills. He has more experience, therefore is more likely to be more skilled, gets paid to race, had a lot of training. He has a C8R. The professional could direct all his efforts toward racing. The race car driver probably has a faster reaction time to hit those tight turns. No kidding. Experience and resources, spend more time in his career, equipment, and focus. Oliver's life revolves solely around racing. I'm sure he even has a psychologist, nutritionist, etc., to make sure he's in top condition to race. Money. Does it for a living, has a team working with him, has done it competitively much longer. Professional coaching. He's got skill and experience. Skill, experience. He drive good, you bet. Got long years experience and background in the racing field. Thank you all, I appreciate that. You know what? You're absolutely right. Now, I want you to tuck that away because let's compare this to us. What's, are these the right, no, I was trying to verify these numbers. I was talking to Professor Tallman and he shouted some out, and if I transpose 212, it's probably still 212. But these are some of your other coding / programming classes, however you might refer to them. We call ours Introduction to Programming and Programming Theory and Practice and things like that. All the other programming courses you had, what's the difference between those and this class, software engineering? Well, it's sort of the difference between software engineering and what I'm going to call coding. Let's take a look at that. What is software engineering? If I can remember the genie reference, I'll tell you after I do this. What is software engineering? Well, it is not coding. It isn't what you've done before. I'm going to refer to coding as programming in the small. Now, don't take offense to that. I'm not saying it's easy or simple, but I'm saying that the things that we create are not large, and they're typically done by a single individual. Coding, what you've done up until this point, is programming in the small. Software engineering, however, is programming in the large. What's the genie's quote in Disney's Aladdin? Phenomenal cosmic power. Itty-bitty living space. The itty-bitty living space is the programming in the small. The phenomenal cosmic power, that's programming in the large. Now, I know some of this is not going to make a lot of sense. I just want to I want to give you some things to hang on as you're reading through the text. What is software engineering? Software engineering is concerned with something that we're going to call software development. Not just coding, not just programming, software development. Again, don't panic. You'll read about what development is. But when you're working in industry, you'll notice that, there we go. Wait a minute, what's going on here? When you work in industry, people talk about development and not just code. Okay, come on. Oh, there we go. The development phase of iOS 16, they're ahead of schedule. Yeah, sure. Well, no. They're done with development ahead of the September launch. Don't mistake development for just coding. There's a lot more than coding in development. Here's how I think about the difference between coding and software engineering. Coding is problem solving. Really, computer science is problem solving. Coding is, at its heart, problem solving. Well, software engineering is part of computer science. So what's the difference? I'm going to add something. Software engineering is professional problem solving. You know all those differences between Oliver Gavin and myself? And yeah, being paid, etc. We're going to focus on a number of attributes of professionalism. I'm sorry you're not going to get paid, but we're going to do professional problem solving, software engineering. We'll be talking a lot about professionalism in this class. Part of what Concordia University Irvine wants you to take away from all your classes, besides being grounded in not only the subject matter, and besides not being also grounded in a Christian worldview perspective, is this concept of professionalism. What are we looking for out there in the workaday world? We'll talk about it. You read a little about it in the text right now. How is software engineering different than coding that you've done in the past? Well, software engineering provides a framework, a structure, if you will. There is a process. There's known good ways of doing software engineering. Professionals do things in certain ways. They follow a framework or a structure. I just got my MBA and I'm here to solve all your problems. Our products are junk and we're completely out of capital. Have you tried using jargon? One of the interesting things about any subject, including computer science, is there's always terms. And software engineering is no different. I mean, even software engineering is a whole term. We're going to have to figure out what it's about. So don't let the jargon bother you. I don't want to sit here and have a list and just memorize what they mean. I'll just use the terms in context and we'll ultimately get through it. One of the reasons I can't blab on, well, I'll continue to blab on, but I can't blab on about the text today is because I have an issue. And as it turns out, my issue is going to be your issue. You're going to help me solve it. I've been asked to develop an app to add numbers. Just tuck that away. Now, just so we all take it seriously, it's a real thing. It's assignment 0. By the way, don't start it yet. We got to talk about it. Don't finish it. We'll start it this time and have some more to say about it next time. But you can certainly look at it. We need an app to add numbers. I know what you're thinking. What the heck? I did that when I was 8. Hang on. Hang on. In this class, we're going to be using Visual Studio. I know that in other courses you've used Studio, but we're going to use it in order to create Windows applications. I was really hoping that I could get Studio 22 for the Mac to do what I wanted to do, but it's too hard. So I'm going to ask you to use Visual Studio for Windows. And we're going to be creating a Windows form application, a desktop application. Now, if you use, I'm going to ask folks in a minute what they use. Windows, Mac, and use Linux. Well, you're on your own. And if you use Linux, you're used to doing all kinds of funny things anyway. I'm going to ask you to use Visual Studio on Windows. You can either do how I do. I'm using a Mac laptop here. I'm running Parallels. That's a virtual machine emulator. You can also use VirtualBox, etc. And I've got Windows running on top of it. And I'll show you in just a minute if you have a Mac. If you have a Windows-based PC, you're all set. Visual Studio is free. No charge for students. Okay. If you don't want to set it up on your own machine, or you got a Mac and don't want to hassle with it, you can use the machines in the lab right next door to your classroom, or at least the classroom you had. Well, you know where the lab is. All right. Would you do me one more favor, please? I just want a survey. Which system do you use? If you have your own machine, is it a Windows? You don't have to tell me it's a Dell Latitude. Just tell me, is it a Windows-based machine or is it a Mac OS-based machine? If you use Linux, you can put that down also. I would just like to get a sense for how many people are using what kind of machine. And it looks to be, yeah, split, which is kind of what you'd expect. So I'm sorry, folks that typically have a Mac, you got a little bit more to do. And you can ask some folks around there, what you need to do is set up a virtual machine. I'm using a virtual machine called Parallels. I think students have a free version of that. VirtualBox is another one. Both of those will run on top of the Mac OS. And then you need access to Windows. Hopefully your IT support department can give you a license key and you can download that and you can be ready to go. If, again, you don't want to hassle with that, it's okay. Just use one of the machines in the lab. And they are set up with Visual Studio. I'm just going to quickly go through this. This is some of the first stuff that you'll read about in the text. And I just want to point out something. I start my text off by referencing two classic encyclopedias of computer science. One is Macmillan, and the other I'll just briefly mention next time, Ralston and Riley. You don't have to know anything about these. But what I wanted to do is I wanted to show you that it's not just my ideas. These are standard, well-known software engineering concepts. One of the things Macmillan hits on is in the beginning, and that's mid-20th century for programming, right? Programming was considered an art form. Now be careful. Many people think art is just whatever. It's whatever I think. Art is what I think it is. It's true that art is created by the artist, but at the same time, genuine art is beautiful, good, and true. If you've had an art class, hopefully your art instructors, like art instructors around here, like Dr. Bell, would harp on this. It's not just doing your own thing. It's expressing something that is beautiful, good, and true. So although there's a lot of art in the development of software, we can't do software development as only art. You know, modern art. I like the frame. Oh, speaking of modern art, well, this one's funny. I just don't understand modern art. Oh, yes, I am laughing at my own thing here. Programming, by the way, is a process. It is a thing to do. Thank you for laughing. Programming is a process. It's a thing to do. And almost anything to do, there's a structure. Trust me, you don't get to take any old car out on the racetrack. Before you can take a car out on the racetrack, it has to be inspected, it has to be certified, blah, 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 blah. And they don't just let anybody out there. You have to have some kind of license or certification. There's a structure to be a race car driver. There's a structure to be an artist. There's a structure to be a programmer. I'm going to refer to this later as professional programming practice. Software engineering, professional problem solving. Developing software isn't just about art. You heard me say this before. You said, what's this all about? This is all about what the president of Concordia University, Wisconsin wants his faculty to focus on. These transcendentals, as philosophers call them: truth, beauty, and goodness. Don't panic. We'll talk about it. Dr. Patrick Ferry is the equivalent of your Dr. Thomas. He's the president. When he came on board a number of years ago here at Concordia University, Wisconsin, he mentioned, I want the university to focus on truth, beauty, goodness, and community. And I internalized that, and I talk about these four in the context of software engineering. So if you're wondering where they come from, they're really coming from my boss, but I think they're good too. You know, Paul, writing to the church at Philippi, talked about this. Whatever is true, whatever is honorable, whatever is just, whatever is pure, whatever is lovely, whatever is commendable, if there is any excellence, if there is anything worthy of praise, think about these things. Good advice for software engineers also. We'll see how that plays out. One other thing I want to mention before we get into actually doing some software engineering is something that I'm going to call the software crisis. Now, when you search online for software crisis, you're going to see lots of different opinions. You're going to see lots of folks who say there's no such thing as a software crisis. I'm assuming they've never used software. Software crisis really says in the development of software, there are three fundamental problems. Number one, I'm doing the past tense here. Software was over budget. It cost too much to produce. Software was behind schedule. It was late. Gamers were not familiar with any of this, right? All our games come out when they're announced. And thirdly, software is full of bugs. I call this the unholy trinity of software development, the three bad things that we're going to use this process of software engineering to get around, get over, and eliminate. We don't want software that costs too much, is late, and doesn't work. We don't. Yeah, ignore that. We'll talk about that later. If you were a student at Concordia University, you'd be waiting for Zeb and Zeke jokes. These are the Zeb and Martha, and Zeke and Mabel, and others are kind of folks in my sphere of joke telling. When Zeb, lives 100 years ago, so they got outhouses. When Zeb accidentally dropped 50 cents in the outhouse, he threw in his watch and wallet too. And Martha says, "Why the heck did you do that?" Zeb says, "I'm not going to go down there for just 50 cents. Oh, I got to laugh at my own jokes. By the way, is there still a software crisis? Just do a search. Software error kept tornado sirens silent in Naperville. Last month, that Naperville is a suburb of Chicago, Illinois. A tornado went through, destroyed lots of property. Oh, sirens didn't go off. Hey, it's not a Bitcoin. How much, what do we call Bitcoin? How much digital currency do you have? Oops, darn. Well, you've seen what digital currency is doing, right? Ooh, why is Google Chrome's latest, what is and how badly can it be exploited? Feds missed 500 million in debts. No big deal, right? Apple released a software update after major security flaw. Equifax, again, those guys can't do anything right. Hackers, zero-day bug, Bitcoin, ATMs. Nissan recalls rental vehicles over. Yeah. Do we have these problems? We do. How do we get over these problems? Answer, good software engineering. In the text, you'll read a little bit about this, a very famous, horrid software failure. After spending $1 billion, that's with a B, $1 billion, in 10 years of development, they said, nope, put it in the bit bucket. They pulled the plug on the project and they got nada. That's not good. Also in the text, you'll read about this chaos study done by the Standish Group. And I've got the latest 2022 figures in the text. But what you're going to see is there's a whole lot of real software projects that fail and a number more that aren't totally good. Wow, we got an issue here. All right. In this class, we're going to focus on this as our structure, as our framework, as the process we're going to use to do software engineering, the software development lifecycle. We'll define its phases and everything later. As a matter of fact, we'll do that throughout the entire course. But for now, the SDLC, the software development lifecycle, is a framework for software development. In other words, it's a way to manage and monitor the project. Yeah, software engineering is about management. Why are we doing this? What's the goal of software engineering? Why do all this stuff? Well, the answer is to create an acceptable, no reason to add usable, but that's part of acceptable, but we're going to focus on that. Create an acceptable computer system. Sorry, my abbreviations, H/W is hardware, S/W is software. A computer system is composed of three fundamental components: hardware, software, and people. Our job, create an acceptable system. Another frequent guest of mine in class is Chuck Norris. If you don't know the Chuck Norris shtick, look it up. So we've been playing What's the Difference today. So what's the difference between Chuck Norris and Tiger Woods? Well, one of these two can club a ball 400 yards with pinpoint accuracy. The other is just a golfer. That'd be Woods. Okay, that's enough frivolity. Oh, no, it's not. What's the difference between a well-dressed man on a unicycle and a poorly dressed man on a bicycle? Answer: attire. 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 How many of you are thinking about dropping the class right now? Don't do it. Folks, I need to share with you a message from the president of Concordia University, Wisconsin, Dr. Patrick Ferry. Oh, do I have it? Tell me, I sure hope you can hear this.
Hi, Gary. This is President Ferry calling. I'm just I wonder if you can help me out with something. I have a board member. He was just kind of sharing a technology problem with me, and well, anyway, I indicated we have a great computer science department, and maybe you guys could actually help us out. What he would like would an app to add numbers, and I told him, well, I know we could do that. At least I have confidence you could. But time is short version, so he'd actually like it early next week. I am sorry for the short notice on that, but if you can help us out, that'd be great. Thanks for considering, and talk to you soon. Bye-bye.
I'm sorry, I had everything turned up, but you may or may not have been able to hear this message from Dr. Ferry. A member of the board is the governing body of the university, has a small manufacturing, I happen to know, he has a small manufacturing company, and according to Dr. Ferry, he needs an app to add numbers. Well, I say let's do it. Okay, are you ready? Off to the lab. Now, we're just going to virtually go off to the lab. But I want to tell you what I'm going to be doing. I want to show you some things in Visual Studio. You'll find what I'm doing as a document online at Blackboard. You'll find the code I'm going to type in just a minute online at Blackboard also. Okay? All right. Now, what I have on my machine, I have an ancient MacBook here, circa 2016. On that, I am running Parallels. Parallels is a virtual machine. It allows you to then install other machines, software systems on top of your native system. So although I'm running the Mac OS natively, what Parallels allows me to do is to run another operating system, in this case, Windows. Now, I hope I can do everything because I'm going through Wi-Fi right now. I'm not connected with a cable. And about once a week, it needs to go use the cable and call back to our license server here on campus and make sure that it's truly activated. And you can see right now it says activate Windows. Well, it's a full license copy. I'm just not connected hardwire. I can't right now because of that. Okay. So your task, if you want to do this on your own machine, you have Windows, search for Microsoft Visual Studio. By the way, the latest incarnation is Visual Studio 2022. And that's just fine. Use that. It's great. In our lab, we have Visual Studio 2019. So my document, unfortunately, is for 2019. You won't have a problem. They're computer science majors. You'll be able to, a little bit different on the installation and a little bit different on the startup, but you'll be able to figure it out. If not, ask somebody else in class, or if worst comes to worst, send me a message and we'll get it taken care of. So I already have, I'm not going to go through the installation process. That would take way too long. Okay. But of course, I'm just going to look for my Visual Studio installation. Here's Visual Studio. And again, I'm running 2019. You run 2022. By the way, there are different levels of Visual Studio. Do not get Visual Studio Code. That's an online thing. It's not going to do what we want to do. Don't get Professional or Enterprise, whatever it's called. You have to license that. Visual Studio Community is free for students, instructors, and people doing just personal work and not trying to create an app for sale. So I'm going to run Visual Studio 2019. Yeah, faster than a speeding bullet, more powerful. Well, that's just sort of the way it is. Now, I have a couple here, but when you get on, what you want to do is the first time, you're going to create a new project. Sorry, many of you have used Visual Studio before, and you're saying, yeah, I know this. Then what you want to do, it'll look a little different, but it's similar in Studio 22, is now you have to tell it, what environment do you want to use? We want to use the programming language C#. Now, first of all, that's scary. You're saying, I haven't used C# before. Don't panic. You've used other similar languages, okay? So don't worry about that. We're going to be creating something in the .NET environment. What's that? And thirdly, we're going to be creating something called a Windows Form app. All right, well, is it going to do anything? Again, the beauty of live demonstrations. Oh, sometimes, as I can remember, kind of in the middle, we'd take a little break. Why don't you do that? You want to stand up? Oh, too late. You want to stand up? Oh, that's funny. When I stand up, I disappear. That's okay. I think it's really hard to just stay seated the whole time. All right. So what do we want? Well, this is already set up. These, pull downs here, I already have it set. I want C#. I want to develop for Windows and I develop for desktop. Okay. So what we want to do is, and there's still choices. We want to create a Windows Form app. So I'm going to select that. And you want to do this no matter what your version of Visual Studio is. It might look a little different here, but we're using C#. We're going to deploy to Windows, Windows Desktop, And we're going to use a Windows Form app. There are other things to do. We're not going to do those. Windows Form app. This probably makes sense. Okay. Give it a good name. I'm going to call it add nums. I like to have Windows Forms in there just so I know. And what should we call it? App -1? Oh, probably can't put a minus sign in there. I don't want to call it 0. Whoa. Folks, you have to be able to type. Okay, did you know that? You didn't see that. How did that happen? Was that like an autocorrect? Is that like Siri? App nums. App is supposed to be add. Oh, that's why I did S's, because it's okay. Folks, you took a break, right? You didn't see any of this. Add nums, Windows Form. Let's call it prelim. If you're using a computer in your computer lab, just be sure location is either pointing to wherever your shared resources are or to your own flash drive or something like that. If you're using a shared machine, you put it on the C drive, other people can delete it, muck with it, etc. Okay. Don't worry about the .NET framework. Just give it a good name. Make sure it goes someplace usable, and away you go. Now, while we're waiting for it, let's talk about the difference between most of the programs you've created in the past and a Windows Form app. Most of the programs you've created in the past, I'm going to call data-driven. Unfortunately, that term has been co-opted. It was co-opted 3 or 4 years ago and means something different. But historically, data-driven meant you run an app, it sits there and it waits for you to type something in, and then it goes on. Versus Windows Form, which are event-driven. It waits for an event, which isn't always just typing in some data. You're familiar with that, right? On your phone, you click something, you drag something. Those are all events. Now, what comes up here, by the way, if you don't see all these things, go to View and just make sure like the toolbox is turned on. Your main design windows here. You don't always need the Solution Explorer, but you need to see Properties. You need to see the toolbox, and you need to have your main design view set here. This is my form. Here's, I'm going to create my Windows application, something that will run natively as an app in Windows. All right. Now, this is not how to solve the assignment. But what I'm going to do, I'm going to create a little form that will have 2 input boxes that will type in 2 numbers, and then a button that will allow me to add them together. This is not how you're going to solve the problem. We'll talk about that next time, but let's play with this just so we can get a sense for Visual Studio creating a Windows Form app. Now, under Common Controls, you can also see this under all Windows Forms, but under Common Controls, by the way, if it's not open, just click it and here it is. These are a lot of things that you can put onto your form, your window. We're going to start with a label. I'm going to click Label. When I go over here, notice I get a crosshairs pointer and I can make a box for my label. Now here's my label, and you notice it says Label 1. Not useful. But under the Properties window, and there's a lot of properties, we'll see more later. Notice it says for this label, the text is by default Label 1. I don't want that. I'm going to say Value 1. So the user knows what to do. The next thing I'm going to do is I'm going to add a text box. So I'll click on text box. Now, we'll talk about, what makes sense, how to lay things out, the user interface later. I'll put it to the right. Value 1, user will know what to do. Type in a number there. All right. Let's add another label below this, Label 2. I'm going to change its text from Label 2 down in properties to value to. And then I'm going to add another text box where the user can type in things to the right. All right. The fifth element that I'm going to add is a button. Rather than being called button 1, we'll say calculate. Cool. All right. Now, what we've done is we've designed our form. This is the user interface. In the bad old days, Visual Studio was called RAD, Rapid Application Development. You can quickly prototype the user interface, but we need some code to go along with it. What I'm going to do then, the event that I want to have something happen with is calculate. So there's a number of ways of doing it. I'm just going to double click on calculate. And when I do so, I'm going to get a new window in my design view here. Notice here, my method is called button 1 click. When the user clicks that button, what do? Okay. Well, what do you do? If you, I'm not going to show you this, but if you switch back to Blackboard, you would, well, okay, I know, I can sort of show you some of this. If you switch back to Blackboard, you will see on there, I just added this just in case I forgot myself. It's not what you see. Week 1 code snippets. Code is given to students on day 1. So you'll find this. It's called Week 1 code snippets. I'm just going to copy this. And now I'm going to paste it into Visual Studio. Right here. Oh, of course. It's, oh, come on. It's not translating over. Yeah. Okay. This class goes until like 9 o'clock, right? Hang on. Let's see if I can do something tricky to punch it over. And if I can't, why would you? Oh, no, don't do that. Up, over, down, around. Oh, I know why. I don't know why. Okay, well, I'll tell you what we're going to do. Just pretend that worked. Don't look at what I'm doing. I'm just going to go to the one that I did earlier that I put all this in. Oh, come on. Windows can, oh, you're not seeing these messages, are you? Use this time wisely and either be reading the text or look up some Chuck Norris facts. Don't spend a lot of time with Chuck Norris facts because I have a lot also, and I want to be able to share those with you. Is this actually going to do anything? Okay, tell you what. One of the problems here is I'm really taxing my ancient machine here. Zoom uses a lot of resources. Running a virtual machine on top of that uses a lot of resources. Windows does, Visual Studio does. Oh, sure. Just make excuses. I hate it when people make excuses. Okay. Test. Oh, wait a minute. Wonder if that's it. No. Where's the one I did? Okay, 11:55. By the way, did you know that it's 2 hours later where I am? Do you know that I am in Wisconsin? And you are in California? Are you holding that against me? Do you know I'm a California native? It's true. I was born in Sacramento, California. Worked in Silicon Valley. Yeah, Wisconsin's all about cheese, my friends, all about cheese. And the state religion? Green Bay Packers. Wow. Okay. Well, here's the code. I'll just, here's the, I'll switch back. Did you notice the tab up top here? Okay. Here's my form. So in the design field, I'll switch back. Here's the code that I put in there. So now what do you do? Well, the answer is, come on, gravity. Oh, no. Yeah, that's good. That's good. So now what you do, okay, folks, I've got 3 layers of things sitting on top. I wonder if I'll be able to get the meeting controls back. Not sure. Press escape. Okay, good. So now that I have all my code, it's a multi-step process. If you've done something different in the past, please do it this way at the beginning. First of all, go to build, the build menu, and say build solution. I should have my output window open. I just don't have enough room. Down here, it should say in a little bit, build successful. If it doesn't, it does say that. If it doesn't, open up the output window, view output, see what's wrong, take care of it. Thankfully, there's nothing wrong. Build solution. Then step 2, debug. And at the beginning, we're going to start without debugging. Debug, start without debugging. Uh-oh, you probably can't see this. My, no. There. Share. Where is it? I don't see it. Okay, I'm just going to do the entire, oh, I'm sorry. I bet you could see it because I have the entire desktop. See this floating thing here? Sure you do. Good. Here's my app. Now watch what happens. Give me 2 numbers. I dare you. Give me 2 numbers. Okay. Oh, wait a minute. Here they come. 10. Okay, I'll take 1, 2, and then we'll do 10 and 5. Let's do 1 and 2 first. 1. Yeah. 1, 2. Now watch this. Calculate. 1 plus 2 is 3. Yes. Notice that pop-up window? Okay. They didn't clear, did they? 5, 10. Calculate. 15. Yes. I wonder if anybody tried to give me a weird, let's see, 6 and 9. Okay, we'll do that one and then we'll stop. It's amusing if nothing else. Cool, excellent. All right, folks. Now, we're good enough computer scientists to know, well, how come we haven't been saving things? Every time you build, it automatically saves. If you want to save in between, of course, you know what to do, right? Save all, blah, blah, blah. Good. All right. I'm going to exit out there because I want to switch back and say a couple logistical. All right. You know what? I should have stayed in studio. This has been a lot. We've covered a lot of ground. let me switch back into Blackboard. And let me just show you that, you know, entering student preview. There we go. So you go to content, unit 1. By the way, there'll be a link under content here that will contain the recordings. So once I get that set up, you'll find the recording for each day and a link down here that says something like recordings or videos or some cool name like that. So there's the text. Be sure to look at that. There's what we would have talked about if we had all day. We didn't. This document here, that's probably a, yeah, it's a Word doc. That doc there, and if I bring it up, you can't see it. That's just what I showed you. Oh, no, it's not. Sorry, lie. This is how to set up Visual Studio 2019. Okay, good. But what you're probably more interested in is week 1 code snippets. Now, we're going to talk more about this next time. What I really, earthquake, what I really want you to do before next time is I want you to dive into Visual Studio, create just what we did right here, just what I did this first day. Do that, get that running. There's a lot of logistical things behind the scenes. You know that, right? Anytime you dealing with a new system, is it configured right? Where did that go? How do I do this? Why can't I see this? So it's creating the code in the app, that's nothing. It's all those logistical things that will take some time and effort and you'll have to think about. And if you run into problems, ask a friend, ask your IT support department, send a note to me, whatever it takes. We're going to talk about this running total idea. This is assignment 0. You don't know enough yet. It's due next Monday. So don't start it yet. I'm giving you today. Wait. Oh, no, that's true. I was thinking it was Labor Day, but next Monday is not Labor Day. Okay, that's good. So be sure to check things there at Blackboard. Woo-wee. That was a whirlwind for sure. Do you have any questions or comments or concerns? Anything in general, maybe about the class or similar kinds of things?
I do have something to say, if that's okay.
Nathan, question. I'm sorry. With you were talking, I could not hear you. I don't know if that was me or you.
Sorry. I actually do have not necessarily
Are
something
you
to ask,
muted
but
or is it just me?
I shouldn't be muted.
I'm sorry. I can't hear you.
Oh,
You know what? I could use that. Maybe if I just don't want to hear you, I'm sorry. What, somebody else here? We can, holy cow, I can't hear you?
I guess so.
Oh, wow.
Strange. Well, I guess to all the
Okay,
students.
I apologize. Everybody else can hear.
Max.
Same as system. Test speakers. I'm not going to do that right now. Okay, I apologize. Probably when I played Dr. Ferry's thing, something got screwed up along the way. Well, that's probably a good place to end since we have technical difficulties. Folks, let me just say the following. I absolutely appreciate you being here in this class. I don't know if you're going to find it fun, but my real goal is I want to give you the knowledge base such that when you're out there, you could start dealing with this. Are we going to become professional software engineers in one semester? No way. But what you will get, I hope, is a sense for what do I need to consider when I'm out there. All right. Posted something in the chat. And now I can't get the chat out. I can't. Oh, good. Something for the students. Well, Will the recording of the class be posted? Yes, you'll find it on Blackboard. There'll be a link under the content tab that will say that. So I apologize, I can't hear you anymore. We'll get those technical difficulties fixed. I appreciate you also staying until the very end. And it is the very end, so we're going to call it good. So folks, have a nice day. If you got questions, contact me. Otherwise, I will see you on Wednesday.